Show that the steps of dividing radicals are similar to multiplying radicals with the following example. So I'm going to break the coefficients down. So 4 over 12. And I have square root of 32 divided by 12. The fractions reduce, so I'm following step 1, reduce. So I have 1 over 3 divided by 8 over 3 because the numerator and denominator is divisible by 4. Next. So I want to write it down so that I can write the square root separately. So I really have 1 square root 8 and 3 square root 3. So I could separate that square root to the numerator and the denominator. So it is bad form to keep the square root in the denominator. And so I need to multiply the top and bottom by square root 3. And so I have, and why is it that, so I kind of did that automatically. So why is it that I'm multiplying the top and bottom by square root 3? So one reason is I can do that because I'm really multiplying by 1. So that's why I'm allowed to do that. Second, well, when we're thinking of, well, how do I get rid of square root 3? And more specifically, how do I get rid of a square root? When we look at square root 3, if I multiply by square root 3, what we will get as a result is square root 9. And square root 9, it simplifies to 3. So if I have just like a monomial, a single term, and a radical and a single radical, what I can do every time is to multiply the top and bottom by the same radical. It's the same radical. And so that's why I do that. And so if I simplify that, I have square root 24 divided by 3 square root 9. And then I have square root 24 simplifies to 8 and 3, but that's not going to help me. So I'm going to split it to that instead. Just kidding. Square root 4 and 6 divided by square root of 9 is 3. So 3 times 3. So I need to simplify it one more time, and what do I get? Well, square root of 4 is equal to 2, and square root of 6 divided by 9.
Question 11. It is considered improper form to leave radicals in the denominator. You must rationalize the denominators for your final answers. What does the word rationalize mean to you? Make sure your answer to the previous question is in proper form. So rationalize means to make the denominator a rational number. Example, so rational number is a number that can be represented as a fraction. So we're dealing with a fraction or integer. So when we take the square root of, let's say, 3. So square root of 3. So you get 1.732050808. That number is not a rational, okay? I can't write that as a fraction. And so we're using that word rationalize to make sure that our denominator is a rational number. Question 12. So as we saw for question 10, we're going to rationalize a monomial, meaning there is no plus or minus between the terms. And how do we do that? We multiply the top and bottom by the radical you wish to eliminate. Meaning, how did I get rid of that square root 3 on the bottom? I wanted to get rid of it, so I multiplied it by square root 3 over square root 3. That will help me get rid of that square root 3, and so that it becomes, you're multiplying it by itself, and so therefore you're going to get you're forcing a perfect square underneath, and so you're going to now going to have rationalize the denominator. So that is the case for a monomial. When you have a binomial, that means that you have a plus or minus between the two terms. So when you do that, you're going to multiply the top and bottom, so the numerator and denominator, by the conjugate of the denominator. Okay, what is a conjugate? So we wrote that on the top over there. Conjugate is when you have the opposite sign for the second term. So the reason that helps us is because we have like a difference of squares going on. So take a look at example B. So see how you have multiplied the first conjugate by the second conjugate? And as a result, by different squares, you have gotten rid of the values that were rational because they cancel out. And you have the other parts which have multiplied. So square root 5 times square root 5 equals 25. You're forcing a perfect square on it. And so when you take the square root of a perfect square, you'll get a rational number. Okay? And so that's why we are multiplying the top and bottom by the conjugate, because of this difference of square characteristic. So let's go through the first one. So 2 divided by square root 6. So you're going to multiply the top and bottom by, well, what do we want to get rid of? The 6. So we get 2 square root 6 divided by square root 6 times square root 6 is 36. And square root of 36 is 6. I need to simplify my term. So I get 1 square root 6 divided by 3, or square root 6 divided by 3, which is more proper. And so I'm just going to just say equals to that. Right? And so why did I simplify? And because it's improper to have root on bottom. Okay, so this was a rationalizing a monomial example. Next part. So we have 6 square root 5 divided by 7 square root 2. Noticing that nothing really simplifies. And so I'm going to multiply the top and bottom by, well, what do I want to get rid of? Do I want to get rid of the 5, the square root 5, or square root 2? Well, I want to get rid of the square root 2 on the bottom. So I'm going to multiply the top and bottom by square root 2. So on the bottom, I'll get 7 times, well, square root 2 times square root 2 is 4. But I should keep the square root sign. So square root 4. On the top, I have 6. Then square root 5 times square root 2 is square root 10. I'm not done yet because I need to simplify the denominator. So 6 square root 10, 7. The square root 4 simplifies to a 2. Noticing that some parts cancel out, so that becomes a 1 because 2 goes into 6 3 times. And so you have 3 square root 10 over 7. Next page. Okay, so we have some monomial examples and then the binomial examples. So skip as you wish and then pause your video and check your solutions as you go along maybe. So part C. Alright, I'm going to rewrite this first off. I want to write it so that it's 1 over 4, so that is fine, and it's not part of the square root. And then I'm going to write it so that I have square root 3x squared. Remember when you have any variables with odd exponents, we want to separate it so that we have the even exponents separately. So I have 3x squared y3. And actually, before I do that, there might be parts that actually simplify if I put it together. So I'm going to write 5x cubed y. What I mean is within the square root, I have a fraction, and some parts are simplifying because I'm seeing the same variable on the top and bottom. And remember, for variables, I can simplify. So I see x squared divided by x cubed. That really means I have xx on the top and xxx on the bottom. So that means my two x's cancel out. That means I have one x remaining on the bottom. And then for the y's, I really have y cubed divided by y is equal to y squared. So that might help me throughout my process. So next, I have 1 over 4. Now let's write the square root separately. I have 3y squared divided by 5x. All right. I forgot the square root 5x because otherwise I wouldn't have anything to rationalize. So I need to multiply the top and bottom by what? The square root 5x. Square root 5x. And so what do I get as the result? Okay, so I have my 1 over 4. I'm going to keep that there and leave it there. So I have the 4 on the bottom there. Okay, 3 times 5 under the square root is 15. And then I have the y squared and then the x. And I have the 5 times 5, which is equal to 25x squared. So I'm going to highlight the parts that are going to leave the square root because they're perfect squares inside. So the 15 has to stay within the square root and the x has to stay, but my y is going to leave because square root of y squared is y. And 4 is fine there. Square root of 25 is 5. Square root of x squared is x. So simplifying that one more time, I have y square root 15x divided by 20x. And that's the final answer. And remember, there's no need for conjugate. Why is that? Well, I was dealing with a monomial, and I wasn't dealing with a binomial. So I'm good there. Okay, question E. Okay. I'm noticing that some parts cancel out. But I'm going to put all of that together. So negative 12 divided by 3 is, I'll just rewrite it for you once. So it's like that. Because if we put it together, we're noticing that things simplify. And so we have negative 4. Square root function, 24 divided by 12. 24 divided by 2 is 12. Are we done? No, we're not. Because we have to go back to the previous rules from way before that says take any perfect squares out, which is a 4 and a 3. So the square root of 4 is 2. So you get negative 8 square root 3. Notice that for part D, you're dealing with not a monomial, but a binomial. So I automatically kind of put the brackets so that I do my FOIL properly as needed. Okay, so if you recall, I need to get rid of the square roots for the denominator. And in order for me to do that, I need to follow part 13 question, which is I need to multiply the top and bottom by the conjugate of the denominator. So I need to figure out what the conjugate of the bottom, the denominator, is. Well, the conjugate of the denominator is, I'm going to write 2 square root 3. Put the opposite sign, so I'm going to have plus square root 5. And I'm going to multiply the top and bottom by the same thing, That way I'm not really changing the equation. So this is the conjugate of the denominator. I'm also going to put brackets there so I do the FOIL properly. So let's do the FOIL. So basically I'm doing, may need some space. So I need to do FOIL. So these arrows help me out. Looks like that. So for the top, let's say we have, some parts are hidden. We have 5 times 2 square root 3, which is 10 square root 3, plus 5 square root 5, minus 2 square root 9, minus square root 15, divided by FOIL on the bottom. And remember, when you FOIL out your denominator, we're going to have it as a difference of squares, right? So difference of squares is going to help me realize that I'm going to have these terms cancel out. What I mean by these terms cancel out. So I want to just write the more simpler ones. What I'm really just going to have is the 2 square root 3. So I'm really just going to have 2 square root 3 squared. That's my a squared, which is 4 square root 3 squared, which is equal to 4 times 3, which is equal to 12. And then square root 5 times square root 5 is equal to square root of 25, which is equal to 5. So that's kind of the process of what's going on in the denominator. The middle parts cancel out, and so I only really need these parts, which are the a and the b squared. Hope that's kind of clear. So I have 4 times 3, and I have 5 based on my side notes. And let's see. Everything along the top, there's no such radicals that simplify. Meanwhile, on the bottom, so I'm just going to rewrite the top. On the bottom, I have 12 minus 5, which is equal to 7. Does this simplify anymore? And it does not. So I am going to leave it like that. Question F. So I need to multiply the top and bottom by the conjugate, which is square root 2 plus 5 square root 3, square root 2 plus 5 square root 3. So I have on the top 4 square root 2 plus 20 square root 3 divided by square root 2 times square root 2 is square root 4, which is 2. So again, I'm trying to do the a squared in my head. So square root 2 squared is 2. I don't want to deal with my plus ab and minus ab, so I'm not going to write that. I'm going to do in my head 5 square root 3 bracket squared. So 5 squared is 25. Square root 3 times square root 3 is 3. Okay, so 4 square root 2 plus 20 square root 3. So don't do anything funny of canceling out with the top and bottom, because remember it's a binomial on the top. 25 times 3 is 75, so 2 minus 75 is negative 73. Only thing is, it's kind of bad form. Well, it is bad form to leave the negative as a negative in the denominator. So I'm going to bring it to the top. So I have negative 4 square root 2 minus 20 square root 3 divided by 73. So it's like I'm bringing this at the front of this bracket, and then I've distributed it. Last part, All the above rules are for square root questions. How can you reduce cube root or other types of roots? So if I had 2, 3 cube root, how would you get rid of the radical on the bottom? You would do the same thing, same idea. You're going to multiply by cube root 3, multiply by cube root 3. Well, actually, if I do it just like that, is it going to work out? No, not really. Because think of how I had said before that when we have 3 square root 3, that's the same thing as writing 1 over 3. And so, if I want 1 over 3 to become 3 to the 1, what would I need to add to that? Well, I would need to add 2 over 3. And so how am I going to change this so that it works out? Well, I need to add a 2 on here, and so that I'm dealing with 3 to 2 over 3, or cube root of 3 squared. So if I do that, it's going to work out, and my logic was trying to get the a rational on the bottom. Okay, and so just an expanded version is so 1 over 3 times 3 over 2 over 3 is equal to 1. All right, so this is kind of my rough work. This is my rough work. Okay, so next, so on the bottom I showed that part is going to equal a nice 3. Next, I need to do 2 times cube root of 3 squared. So I have 2 and then 3. Well, I prefer to write these more complicated exponents as in this form. Well, 3 squared is equal to 9. And 1 cubed is equal to what? Well, I'm going to have to write that as 2 cube root of 9. I can't really simplify that anymore. And so if you notice, I just added the dots here to make it all proper form. And so that is my final answer.